Welcome, good morning. Thank you for being here. Please keep drinking your coffee, and hopefully we'll make this entertaining somewhat for you guys. Today we're going to talk about automation. We are really just going to scratch the surface, but we want to talk about automation, Palo Alto Networks, and how does it all work together with the Ansible from Red Hat. And we'll show a couple of use cases on how we use it in Palo Alto Networks. We're going to show you some of the best practices on how it should be used. And then the rest is kind of to your imagination and creativity. My name is Ivan Boyer. I am part of the developer relations team here at Palo Alto Networks. And if you guys have been at the general session yesterday, apparently I'm the main, I'll show you in a second, threat actor. I had no idea about this. All the logs had my name. So I'm not sure if somebody trying to tell me something or whether I have a job after this, but that's my secondary designation here. And I have honor to have Stanley with me.
Hi, my name is Stanley Caranditu. I work with Red Hat. I'm an automation architect. I'm a long-time Ansible user, but I have used other automation frameworks like Puppet and Chef. And it's going to be an honor to talk about firewall automation.
We are very happy to have Red Hat with us here today. Thank you, Stanley. So let's kick this off. So let's start by saying that if you listen to general session, you've probably noticed that automation is really important for us at Palo Alto Networks. And so automation means many things. You can start from the basic cornerstones, like the tools that we're going to talk about, all the way up to remediation and SOAR type of models and everything else. So one thing which is just re-emphasizing the message from yesterday is that in tomorrow's world of cybersecurity, unless you can automate, you're going to be dead in the water. There is no way that all the tasks that you need to perform and do as a DevOps guy, as a Sec DevOps guy, if you try to do this manually, you're just going to go crazy. And honestly, I drank the automation Kool-Aid probably 10 years ago. Wasn't even related to the cybersecurity back then. And pretty much in my rule book, if you need to do something 5 times the same way, that got to be automated. That's definitely true for the cybersecurity and how do you remediate and how do you answer to the threats out there. So now, let me step back a little bit talking about the criteria. So when we started looking at automation tools here at Palo Alto Networks, there was a whole slew of them, and there is probably still 50 plus of them. Maybe 5, 6, 7 most important ones, but then a bunch of the others that you've heard or never heard of. But we had some hard requirements for automation tools on our side. And our number one requirement was that whatever automation tool we use, it has to be agentless. Us being a security company, providing you guys with a hardened appliance, really leave no room for running a third-party agents on our appliance itself. So therefore, all the automation tools that do need agents were really kind of out of the scope. Oh, okay, maybe I should use this. The second criteria is that when you look at automation tools and automation itself, most of the DevOps, and back in the days, again, 10 plus years, DevOps was just kind of being forming as a title, as kind of profession. They looked at them as guys who were stuck in between system engineers and software engineers, and kind of in between, whether by choice or because they had to. So lots of them really don't want to learn 1,000 languages out there to understand how to automate your device. They want to really deal with the automation tools that are simple to use, usually text-driven, and once you learn the syntax of one of them, you can use it all across different vendors. So, trying to learn Go and Python and Java and C++ and all the other stuff that software engineers like to do was a no-no for DevOps guys. So that's really important to keep in mind, because when you look into your company and your DevOps culture, from what I've seen, you'll see your DevOps culture, which comes from, say, a kind of Python background, and they're going to like a certain set of the tools. It's going to be really hard to change their mindset. Or you're going to have a different set of the DevOps culture, which comes from, say, a Go realm, and they're going to like a different set of the tools, and it's going to be really hard to change their mindset. one important thing that we've noticed at Palo Alto Networks is that in nowadays of the cloud and the hybrid cloud and even on-prem, the DevOps culture is the culture that actually evangelizes your product. So if you can hook up them with your product and make it easy for them to use it, you already won. If you try to go against the grain, it's really very slow adoption and hard to adopt it. And the last but not least, in our case and in many other cases, there are always little intrinsicies about how do you need to do some custom operations that are not common across all the vendors. So the automation tool that we had to choose had to be extensible and easy. We'll talk more about it a little bit later, but the bottom line is that we, as any other vendor, we are very innovative in how we develop our product. So some of the features we innovate are very different than anybody else. So we really need to be able to extend the automation tools quick and easy. And therefore, there comes Ansible. It is agentless. There is no reason to install any third-party code. And I'll show you in a second in a little bit more detail, but we were able to extend it to use our Palo Alto REST APIs, which is a little bit unusual way to use Ansible, at least 4 or 5 years ago when we started with this. It's really simple. All the Ansible playbooks are text files. You can use your favorite editor to edit them, whether it's a VI, Emacs. So I started speaking this lingo now. It's crazy. Or Notepad. You don't need any special coding skills. All the tasks are executed in order. It's kind of really simple to understand, and once you adopt the philosophy behind Ansible, you can really use it with ease with our appliance or any other appliances. And it's extensible, as you'll see. For us, it was important that the modules that are used in the Ansible are written in Python, because lots of our DevOps culture comes from a Python background. So that was important. So that helped us with adoption within our company too. As far as the kind of common tasks that we use and we execute against Palo Alto Network devices in Palo Alto Networks, our task is quite often frequently executed. So think about deploying a topology in a cloud as extension to your on-prem data center, where you need to develop and deploy like 10,000 containers. So you got to deploy, number of VMs in hundreds or thousands, So for each of those that are deployed, you usually have to go and do something about your device, so they are aware about what's going on. So the tasks are really atomic in size and small, and they happen very frequently. And Ansible works very well with that. They're simple to perform. Like I said, they're atomic tasks. It's usually, okay, please go ahead, change this one rule. Usually you set your golden image and base templates to bootstrap the firewall, and then after that, it's kind of incremental, kind of day 2 type of operations, right? And they gotta be error prone, which means you will come up with your golden playbooks, golden templates, and once you have them done, really you can monitor the change sets on them, you can monitor, audit them, what changes, but really there is very little that can go wrong there. Really the only thing that can go wrong, at least in a way how we use it, that uses the connectivity between your devices and the Ansible management platform. But we all know a network is 99.9% up nowadays, right? So how does it work with us? So like I said, we started using Ansible in a little bit unusual way. Ansible itself, back in the days when we started with this was before even Red Hat acquired them, common use of it is that you would set up your playbook, and then you would execute your playbook, and what would Ansible do with the SSH into the host? It needs to change, and then execute a bunch of commands over there, right? That didn't work for us, because we do have a CLI interface, but we really don't want to SSH into it. That's kind of old school stuff. We really have an APIs, which we want everybody to utilize. And the one thing we did really well as a security vendor back in the days is that from day 1 almost, all our devices had APIs, public APIs, which allow anybody to integrate with us. So the very interesting thing about it is no matter if you're using physical firewall or the virtual VM series firewall or even our management platform called Panorama, they all have the same APIs. They're really very little different in how these APIs look. So once you write your playbooks, once you write your custom scripts to interact with any of these APIs, we can run them against any of these devices. It's one ring to rule them all. Kind of. I'm just trying to see if you guys are still awake or what's going on. Anyhow, the way how it works with us is that you would go write your playbook on the left side, and I hope you've seen Ansible playbooks. This is a very simplistic playbook. You'll probably need something more than this. But that playbook would be executed on your management console, which runs all the Ansible libraries and everything else that you have set up, usually owned by your ops guys or DevOps guys. And then that tool itself would then execute our modules. Our modules are really a shims which work between our devices and Ansible itself. And what they do, they convert the playbooks and the calls in the playbooks into the API calls to our devices. They also do depend, just as a side note, a little bit more details, into our SDK that we develop, which is just the Python SDK, but that's kind of pointless in a way, because ultimately it all gets executed against the API call. So now, that little playbook on the left side, which sets DNS servers and a couple other parameters for the management, are all actually API calls down the line across the wire. So we've started, like I said, this journey a long time ago. A long time ago, when Ansible was kind of just starting up to become known and really interesting before Red Hat. It was about 2015, I think, something like that, and we started looking into that, figure out all the criteria I showed you guys, kind of makes sense. Let's go, let's do it, and go ahead and start developing it. And since then, what happened is that, and which was our goal, was actually we did want some of these modules to be contributed by our community. And what we're having right now is about 10 plus guys or companies contributing to our Ansible modules, which helps them manage and configure Palo Alto Networks devices in their networks. I mean, some of these are internal. Our IT is using Ansible too, so they also contribute to it. So pretty much beyond our developer relations team, we have a couple guys helping us with this. There is about 20 plus modules that we developed. So now, what does that mean? You can configure many things in our device. There are so many knobs, really, that you can drain yourself into to do this or that. We have like so many features. So we're trying to accommodate this by creating modules which will help you configure different parts of the system, whether you want to configure, obviously, security policies, whether you want to configure your net rules, whether you want to configure, I don't know, IPsec tunnels, whether you want to integrate with AWS, metadata service, doesn't matter. But our ultimate goal is not to have all these 100% covered. Our ultimate goal is to have 60–70% of the most common tasks covered, because what we've seen with our customers is that they really use about 60–70% of these capabilities on day-to-day basis. And they usually automate only that many of them. If they need to turn this other knob that we just exposed in the latest release, they will usually do it manually. And then they will sometimes give us feedback and say, hey, we really need this. On some of them, we'll just write them themselves one and contribute it to us. So down the line, we do need your help to give us a feedback and say, hey, this is what's missing. This is what you guys need. Or if so you choose, it would be awesome if you can contribute some to it too. So now, ultimately, the benefit of the whole Ansible and the way how we look at this is this new term that's being coined lately. And it means so many things. It's so ambiguous, so I kind of hate to use it, but I'm going to use it because it's going to ring, has a good ring to it, and it's really having security as a code. So now, we can go in a weed of this, saying, what does this mean, and we can talk about it after this. But for us, what this means is that many customers came to us and said, listen, I like what you guys do. I like the features you guys have. I have this DevOps, I have my developer community in my company. They don't really care about security. I cannot teach them, for God's sake, if they need to do something about security with the code. On the other side, we have our security ops guys. Of course, they only care about security. And these two teams collide all the time. Developers, they want to be agile. Developers want to churn the code as quickly as they can. That's the new way to do it. This is how it needs to be done. In a cloud space, you have release every week sometimes. It's insane. Security ops guys, no. They want to see what's going on. They want to open these ports, those ports. They want to make sure that, ServiceNow gives them a ticket for that. They want to review it. It's going to take 2 weeks. And then they're going to open this port. OK, Mr. Developer, go and do your stuff. That doesn't work together. So they ask us, OK, we need help with this. How can you, Palo Alto Network, help us with this? So we looked into this problem and figured out that the one way to do this is that we can integrate our product in a CI/CD pipeline. So now, for those that might not know, CI/CD pipeline is just a typical way how you would integrate your code into your product and deploy it, on like weekly, daily, whatever is your train, kind of how often you send your releases basis. And really, this is an automated pipeline, which just happens quickly, and really, you don't want to deal much about security, much about what's going on, how you do this. Developers really cannot wait 2 weeks for security ops team to open up the ports or open up applications for them. So that was a challenge. So we looked into this and said, OK, well, hey, we have Ansible. We're already automating a bunch of stuff with our firewall. Our device usually sits somewhere at the perimeter edge within whatever it takes to look at the traffic. So how do we make it work? So what you see here on this PowerPoint slide is kind of a typical CI/CD pipeline. And they're all different. Every company has a different requirements. Every company does it different way. This is like kind of basic one that pretty much everybody starts with. I'm not going to talk about benefits of this, but smaller companies, without this, really, you can't scale easily. There's so many benefits of doing this. But usually the flow goes, a developer updates the application or creates the application. It's usually stored in some source repository, say GitHub in this case. We are familiar with GitHub. GitHub kind of gets the new code. It triggers your build server. Application code is checked out. It's being built. Goes all the unit tests, all that good stuff that needs to happen, as a good development practices. And then what happens if that passes? You can inject your security into it. And again, you can inject security at the beginning to check your code, and in any of these portions. But if you figure out for the network perspective, this is a good place to inject security. And in our case, and I'll show you the demo shortly, once the code is checked out, it's pristine, it's kosher, it's clean. We're going to trigger the Ansible playbook, which is going to go to the firewall and say, hey, Mr. Firewall, here's the set of the metadata this application needs so the users can access it. And the users can be internal users in a staging area for a Q&A, can be production area, right? Whatever, however you deploy this. They're going to be invoked, and bam, automatically, it's all done, right? Firewall gives you access, and everything's great. So now, this doesn't take away a control from the SecOps team. Because in a way that even our firewalls are deployed, you can always set up the rules, pre-rules and post-rules that nobody can change. Catch-all rules, the rules that make sense for you. I don't allow Telnet, I don't allow FTP, Facebook, whatever, pick it. But it does allow developers to set their own rules. So I'll give you an example. If your SecOps teams will set up and say, hey, I will allow you guys to do web browsing, so your application, you're showing some data, maybe it's a shopping cart, whatever. I'm going to allow you to do this, but I don't really care whether you run this on port 80, port 880, port 500. I want to make sure it's a web browsing traffic, HTTP traffic, or HTTPS. Everything else I don't care about. So you can set up the rule in our firewall, say, hey, first rule, I'm only going to allow HTTP traffic. And then the next rule is the rule that developer will automatically inject, saying, well, this is going to be running on port 80, 880, everything else. We're going to look into the traffic itself. It doesn't matter for us. We're a layer 7 firewall company. We can see what's going on, no matter which port you're running it on. We can know that it's HTTP or HTTPS traffic anyway. So it kind of makes everything works together with this. And with no further ado, actually, I'm going to show you how this all works together. And hopefully it's going to make even more sense. So okay. So I pretty much deployed what I showed you in that picture. And it's probably a simplistic, very simplistic, you guys can see that, okay. Very simplistic CI/CD pipeline. So what I have a firewall deployed in AWS, which fronts our business, line of business application, which is just the NGIX server. That server is running as a container in the Amazon ECS. So now I throw a lot of keywords here at you guys, but basically it's a container running behind the firewall, running on AWS. So now I'll show you how, as a developer, I can go and change my port for my NGIX and my content of the server itself, and you'll see automatically how it all fits together, everything gets deployed, and everything just works. And I'll show you how Ansible plays a crucial role in that. So, okay. So currently, just to show you, we have some policies. It doesn't really matter, a bunch of different policies. One of them is to allow access to this application. This application is running on a specific port. Let me actually double check what the port is. It's running on port 8095, okay? Whatever, it's just that. And it's really, our favorite application, Hello World. I'm gonna, kind of refresh it. Hello World, okay. So I, as a developer now, will gonna go and figure out, well, you know what? I don't want to 8095. I mean, what is that? I'm gonna run this in different port, and I'm gonna actually make sure that, as I push my code into the pipeline, I have access to it. So I'm going to go and look into, so there's just some code here. This is all on GitHub. If you guys want to play with it later on, it's fine. So this test definition, just so if you don't know, is nothing special. This is what Amazon expects you to do. So this is no magic here. This is exactly a template that they would need you to do for any container instance. So I'm going to change this port to port 8090, for instance. I'm going to save that. And I'm going to change my application just a little bit to kind of show you that actually this is not all pre-canned. I'm going to add a logo to it. And then, this is my change the code. And I'm going to now push this code. Into my GitHub repository. And what's going to happen next is that my Jenkins will detect the change, hopefully. There you go. So it detected something has changed on the GitHub. Okay, so not a big deal. This is how everything works from 20 years ago. But what's interesting piece about this is that, if you look into this job that is running, and don't worry about details right now, it doesn't matter. There's a bunch of stuff going on here. But, first thing is going to go and build my container, checks that everything is kosher, just kind of builds container stuff. That's container magic. Then eventually, once everything checks out, it's going to run my Ansible tasks, which are here, and they will actually go to the firewall and update the firewall with the new ports, with new application credentials, and everything else. So now, we are parsing that file I've showed you guys, which is just a common file to extrapolate some of that metadata. This is super simplistic case, extrapolating only port and IP address. But you can imagine that you can build it to extend it as much as you want, to whatever you want to do. And eventually, when this is done, and it's done, if I go back to my code and look at port 8095, you'll see that I don't have access to it anymore because it's changed. You're going to have a spinner there, spinner of death going on forever. But if I go back to the port 90 that I did change my application to, there you go. It's all deployed. And obviously, you can just even double check with Amazon itself to make sure that this is just my container running, and just to show you. It's running on port 8090. Bam, done. So as a developer guy, that's all what I have to do, nothing else. Okay. Was this interesting? Good job, bad job? Give me more coffee? I don't know. Okay. Let Stanley tell us a little bit about, oh yes, okay.
Thank you, Ivan, for that demo. In this next part of the presentation, we're going to talk about automation thought process, right? So you've decided that you want to automate your network and you don't know where to begin. So this next section is basically going to talk about 2 examples. I want to focus on firewall object management, and within that, I want to focus on 2 things. The first one is address object management, and then address group management, right? How does that look, right? I'm going to use it as an example to discuss some of the thought process that you have to do when you want to automate something. So if we first look at how to begin to automate an address object, this is how you do it in Ansible. There's 3 pieces to this. The first one is, what am I connecting to? I'm connecting to a firewall. That's underneath IP address. You have to give some sort of credentials, so you have a username and a password. And then finally, at the end, you have the address and the address object keys, and that's what defines what address object that you're going to create. So if I execute this using the Ansible playbook command, that's generally in Ansible, that's what you use to basically run an operation. Then it will connect to PanOS Firewall 01, log in with the admin username and that password, and then add that address object. So great. You've just created your first automation task. Now the problem is, if you want to go ahead and add additional address objects, you have to modify this file, right? Also, if you want to change which firewall you're talking to, you have to also modify this file again. A best practice when it comes to automation, regardless of whichever automation framework you're using, but especially with Ansible, is you don't want to be changing your playbook file, right? So how we handle that, and we're going to make some improvements here, is we're going to first identify what are some of these keys in there that we can make into variables. So one is, of course, the host. We want to basically point to different hosts. We want to be able to change, we basically want to have a dynamic way to add the address objects. And then the last one we'll deal with is, my password is in clear text. I'm a security guy. That's not a good thing to do, right? How do we deal with that? So in Ansible, what we do is we basically change this playbook, transform it a little bit, and we begin to convert some of those static keys, and we attach variables with them. In Ansible, how you do variables is you do these double curly braces, and you put the variable name in there. So in this case, we'll first tackle how to dynamically add address objects into this particular firewall. So we do it like this. We change the address key. We give it a variable called newhost_address, and the address object key, and we give it a variable called newhost. The Ansible playbook command changes up a little bit. So now you are just not only calling the playbook, but you're also adding in 2 extra arguments. And now this is cool. You can now run this playbook again and again, change the variables. Instead of pointing it to 192.168.1.2 and MySQL 02, you can change that up to a different address object, and now we'll add it. So that's great. So we've gotten now to the stage where if we need to add new address objects into the firewall, we don't have to change the playbook, right? Again, our ultimate goal when we're done with this is we want to have a playbook that we never have to modify, right? And that makes it portable, that makes it scalable. So that's great. Now, what else can we change? Remember we talked about the hosts. So, sorry, before we talk about the host, there's some further things that we can do here. Here, notice that we're putting a IP address and a host name. When I was doing this, I realized, hey, I think I can automate that. I think I can not have to do that. And the way we do that is we identify the process that we're doing, right? So the process that we're doing is we're taking a host name, looking up the IP address, and then putting it into a variable. Wouldn't it be cool if just Ansible could do that for us? And the answer is yes. Ansible can do that for you. The way it does that is through a concept called a lookup. A lookup is basically a function within Ansible that allows you to talk to an external service query an external service and say, hey, this is what I'm looking for, and it will return back to you a value. In this case, we're using a lookup service that queries DNS. We put in the host name, and it will return back the IP. So what we've done here is we've basically taken a task. So part of the task of creating the variables requires us to do a lookup. Now we've taken that lookup process, and we've now have Ansible doing it for us, right? So yay, this is part of what you do in automation, right? You want to look at all the different tasks that you do, and you want to see, hey, can the computer do this for me? And if it can, have it do it for you. So that simplifies the Ansible playbook command. Before, it had 2 extra arguments. You had to give the new host address, the new host variable, which had the DNS name, and also the IP. But now all I have to do is just give it the host name. Right? So we went from that, where we give an IP and a host name, just to only the host name. We're making progress here. So next, we want to tackle the host, right? If I want to point to a different firewall, again, I have to change the playbook. And what's the rule? The rule is I don't want to be changing the playbook. How can I fix that? And this is how we solve that in Ansible. We use some special variables that Ansible provides you. Ansible host, Ansible user, and Ansible password. Whenever you call these particular special variables, it will look up this information from somewhere else and inject the name of the firewall, the username, and the password. If you try to run this just the way it is without bringing in this extra file that we'll talk about in a second, the playbook's going to fail. It's going to tell you, I don't know what address host is, Ansible host is. I don't know what Ansible user is. I don't know what Ansible password is. So let's talk about this additional file. This additional file, traditionally, by convention, is called inventory.yaml, or just inventory. And it can be written in multiple formats. I prefer YAML. You can write it in JSON and also in INI format. And all it has is information about your inventory, the host that you want to connect to. And in this case, I put in that information about the firewall. I give the firewall name, the password, and the username. So typically, you put this file in the same path as the playbook. That's just by convention. You can put it anywhere, but by convention, people just put it there. Now, we modify the Ansible playbook command. And we add the -i option, and we give it this inventory file. Now, when we execute this whole command, it will do exactly what we expect it to do. It will basically add this address group onto PanOS Firewall 01. It will use the username and password to log in and do the right thing. It will also do the IP lookup to get the IP address, and all is good. It should work just fine. So there's one thing, though, here that we really haven't covered is the password, right? The password is still clear, right? If anyone gets access to this repo, then now they know the passwords of your firewall. So how do we solve that? There's a couple of ways to solve that. I'll show you what is the most scalable way to solve that. There's a tool that sits on top of Ansible CLI. It's called Ansible Tower. You can think of it sort of as an API for an Ansible playbook. It's what ServiceNow or Jenkins would interact with in order to basically kick off a whole bunch of Ansible plays. The structure of Ansible playbook of Ansible Tower is as follows. You have something called an Ansible Tower project. All it is just a pointer to the Git repo that has this playbook. And yeah, it's pretty straightforward. The next thing is you have to create what's called an Ansible Tower inventory. And all that is just all that inventory information that we saw in the last slide. So we take this information here, and we add it into that object. It can be added statically, but at scale, people add it in dynamically using dynamic inventory scripts that query some kind of configuration management database that has all your inventory listed in there. Now, this is the good part. So Ansible Tower has the capability to store credentials in a separate store. It stores it securely inside of a database. So that's where you'd put in your username and your password information. Then you have to tie all this stuff together, right? Because you want to execute the job. And the construct that Ansible Tower uses is called a job template. So you tie in a project, an inventory, a credential, and you tie it into a template. And when you execute the template, it'll do the right thing. It'll add the address object into the Palo Alto firewall. The beauty about this is that now you have this job template where the person executing the job does not see the password, right? What they're going to see is this. Hopefully it's not too unclear. They're basically going to see a playbook that they can run, the inventory that they're using, and then this pointer to the credential. But they don't actually see the credentials. It's hidden from the person actually executing the job. So now I've managed to hide the credentials now. So the person executing the job doesn't need to know the credentials, and they're still able to do their job. So this is a power of Ansible Tower, and this is why a lot of customers use it, to give them that ability to basically run automation jobs in a scalable way and still maintain some level of security and management over playbooks and inventory. So it's just an example of using a form. In the form, you can basically put in which host you want to add, and it will do the right thing. So we've covered how we can basically take a playbook, initially starting off just as doing a simple task, just adding an address object into a single firewall. We've taken that to the point where we have a playbook, and in the playbook, we don't have to change anything in the playbook. We just feed it a bunch of variables, right? So the playbook stays static, following best practice, and now that playbook is now able to add address objects to different firewalls or to add new address objects to the same firewall. The question now comes is, that's great, but if I want to play with all this stuff, where do I begin, right? If I run Ansible playbook command on my PC, it doesn't work. So how do I install all this software to begin to test it out? This is basically how you set up Ansible on a Mac. Ansible runs on Linux and on Macintosh. Windows people, please use VirtualBox to install a CentOS VM and run Ansible from there. Sorry. And on a Mac, this is basically how you do it. You install Python. You install a program called PIP. PIP is a Python package manager. And then you use PIP to basically install Ansible and install the PanOS Ansible modules. I won't go through this fully, but in Python, Python has the same concept as sort of what Docker is to an OS. You can basically take some Python code and isolate it from your system. This is how I'd actually recommend that you deploy it, because then it doesn't modify any of your Python system files for whatever reason. If you have a corporate laptop and you don't want to mess it up, this is the better way to install Ansible and all the Palo Alto dependencies. You can think of it as Docker for Python, right? It basically takes a bunch of Python code and separates it out from the system, and it runs sort of in a container, in a folder. So we've just covered address object management. Now let's look at something a bit more complex, address groups, right? So my understanding of address groups is just a list of address objects. I won't go into the code. I'll basically show you conceptually how you'd go about solving this. And I have a demo that you can point to at the end that you can go play with this. Because if you see the Ansible code, you can really get kind of lost, because I use some few advanced features in there to solve this problem. But conceptually, what your Ansible playbook command would look like is basically you defining the name of an address group and the list of objects, address objects that you want in that address group, right? So how would I go about beginning to solve this? So the first thing you do is, okay, let's write some pseudocode. Let's sort of figure out the steps in which we want to sort of solve this. And these are the steps that I came up with. First, I'd like this playbook to essentially create an address group if it doesn't exist, right? If the address group already exists, then give me the list of hosts that the address objects that are associated with that group. Then looking at the list that I've provided that I'm feeding into Ansible, compare that with the list that I already got from the Palo Alto firewall, and add in the missing ones, right? So whatever ones are missing, add them in, take the host name, convert that into an IP, and create a proper address object, and then attach it to the group. And then finally, remove any of the address objects that I haven't defined, right? So in this case, what we're doing is kind of doing what Ivan sort of alluded to before, where you want to convert your configuration into infrastructure as code, right? You want to basically have a outside data structure that defines what your configuration is, and then push that through Ansible to your firewall, and that's what your firewall will basically be configured as, right? Typically, when people do things that way at scale, they get much better auditing. They're able to audit things better, and they're able to make changes faster. They're able to recover faster from any major, data center meltdowns and things like that. So you can find this demo at this link. I assume everyone's going to get these slides, so just look it up over there. And the command to execute it is going to look like that, exactly what I spoke about at the beginning. There's full notes in the README. I go over how to install all the dependencies and how to execute the task. And of course, you have full access to the code, so you can study it line by line. I'm glad to take any questions. Just open up a GitHub issue, and I'll be able to answer any of your questions. Now, the last thing I want to talk about here is showcasing extensibility. So notice in here, Ivan was talking about the fact that Palo Alto do something that is a little bit different than what the Linux folks would do. The Linux folks, whenever they call their modules, they don't put in any host information, right? They just have whatever the name of the module is, and then whatever tasks, whatever sort of module arguments they have, but they don't have any information about how to connect to the host. Now, the reason why that is the case is because Ansible, by default, ships with what's called an SSH connection plugin, right? How do I connect to the host? So somebody wrote a piece of code that says, this is how I connect to a host that's running SSH, and these are the things that I need to do. The same thing can be applied to PanOS. So if any of you are Python developers and want to take this challenge, please see me after this, see me after this talk. I'd love to show you how you can go about doing this. This has been done for network switches. So before the current release of Ansible, when you had to connect to a Cisco switch or an Arista switch, you had to do the same thing. You had to, in your module, specify the host name, the username, and the password. The folks who manage these network modules wrote a connection plugin where you don't have to do that anymore. The connection plugin name is called network_CLI. But in this case, for PanOS, it is possible to write a connection plugin written in Python. It's not very hard. It would take an intermediate Python programmer maybe a couple of weeks to sort of hack it out. But what we now have the capability to do is not put in that address information in there anymore on how to connect to the host. So this is showcases the extensibility of Ansible, where you can make a pretty major change. I mean, this will simplify your playbook significantly without having to talk to Red Hat. And Red Hat would gladly accept this fix if you manage to get it done. They would welcome it with open arms. Here are some resources that you can use. Just talking about the network modules that PanOS has developed, that Palo Alto have developed. Ansible Galaxy, they've created some roles. the GitHub repository for the PanOS modules if you want to grab the latest one. And Palo Alto has a community space where they talk about Ansible, all things Ansible. I think, are you one of the moderators? Okay, and Ivan's one of the moderators. All right. So, questions? Sure. Can you answer that, Ivan? He's talking about if there's AAA issues.
So if I
Sorry, you want?
So we don't use SSH for our PanOS modules. We use the API calls. There are two ways you can obtain credentials and log into the Palo Alto Networks device. One is using credentials, putting them in a vault, putting them, hiding them away in different ways, or using API key. So you can generate a one-time API key and use that in our modules instead of the credentials. Yes, the question was if the slides are going to be available. Yeah, they will be after the conference. Okay, I guess then we're done. Thank you very much.
All right, thank you.